You've got to decide ionic or molecular. What? 2 nitrogens, and then mono means one what? Oxygen. You have already learned about ionic compounds. Now we're going to switch gears. Molecular compounds are way easier. But first, you need to memorize the 7 diatomic elements. Now, di means two atoms. So there are 2 atoms bonded together. So there are 7 elements that occur diatomically, like not alone, but bonded to their own kind. So they are hydrogen, oxygen, and nitrogen. I like to call these the big 3. And then the other 4 are halogens. And so if you look on the periodic table, you will see that they kind of make like a 7 on the periodic table if you throw the hydrogen in there. So just memorize these. That doesn't mean that oxygen is always going to bond to oxygen. It will bond to itself or another element. Okay, so if we just have elemental oxygen, it's O2. So guess what his name is? His name is the name of the element, oxygen. His name is hydrogen. Nothing fancy. Those are just diatomic elements. Now let's get into the naming molecules. First of all, how do you recognize that something is a molecule? You've got to decide ionic or molecular. What we're looking for is 2 nonmetals bonded together. So I've got a couple compounds here. N2O5, nitrogen and oxygen are both nonmetals. And then carbon dioxide, you recognize that. Carbon and oxygen are both nonmetals. So that tells me, ding, 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 that is molecular. And so we're going to use these rules. You've got to decide. It's like French and Spanish. They're 2 different languages, and we've got different rules and different structures. So ionic and molecular, 2 different worlds, 2 different ways of naming. Molecular compounds are named with prefixes, and this is the list of prefixes I would recommend that you memorize. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And those are common. You've heard of these before. So let's get started with our rules for naming. So the way we're going to do this is the first word, the first name, is the prefix of the first element and the name of the first element. So the prefix for 2 is di. The name of the first element is nitrogen. All right, that is the first word. Easy, right? The prefix for the second number is penta, penta for 5. And then the root of the word is, well, the element is oxygen. The root is going to be ox. And then we're going to drop that ending and add an "ide" to the end. Now I've got too many vowels going on, and so we're going to call this pentoxide. So that was the prefix is pent. The root of the second element was ox, and then we have an "ide" on the end. After you see a couple of these, you'll be used to it. Now the next one, here's one more little rule. If the first one is a single, the prefix for 1 is mono, but you've never heard that called carbon dioxide. If the first element is a single, you can drop the mono. So that is just carbon, and then the prefix is di, the root is ox, and then we end it with an "ide," carbon dioxide. And then over here, I think you noticed the second one here. Guess what this one's called? Carbon. But then we definitely need the mono here, monoxide. Carbon monoxide, and then carbon dioxide. All right, now I've got a name, and then we're going to write the formula. This is actually easier going this direction. So what does di mean? Di means 2. 2 what? 2 nitrogens. And then mono means 1. 1 what? Oxygen. Dinitrogen monoxide. The next one is sulfur. There's no prefix there, so we have to assume it's a single. Sulfur And then tri, that prefix means three. Three what? 3 oxygens. Sulfur trioxide. Getting the hang of this? It's pretty easy. Phosphorus, there's no prefix mentioned, so we'll just use a P. Penta means 5. 5 what? 5 chlorines. So PCl5. And that is how you write names and formulas for molecular compounds that are binary. So you just need to memorize those prefixes and then a little practice and you'll have that down pat.